Okay, in the last class we have discussed about the interfacing of a simple LED light emitting diode to 8086 and then a simple switch. Okay. So I have given the example of one input device such as switch and output device LED. Today we will discuss about how to interface keyboard, which is one of the major input block for any microcomputer. Okay. How to interface a keyboard to the 8086. Interfacing of hexadecimal keyboard. I am discussing hexadecimal keyboard. As the hexadecimal keyboard implies, 16 keys will be there. So we have different types of the keys. Normally we will use the mechanical switches, push button type of thing. Okay. So here we have to connect the 16 keys in 4 rows and 4 columns. So we have to use 4 rows and 4 columns. So these are 4 rows and we have 4 columns. These 4 columns will be connected to power supply of plus 5 volts. Then the switches will be arranged here at the cross sections. This is one switch. If you press this push button, the switch will be closed. This is another 0 switch. 1, 2, 3. We have 4, 5, 6 and 7, 4, 5, 6, 7, 8, 9, A, because hexadecimal 10 will be A, B, this will be C, D, E, F. This has to be connected to the ports of 8255. Okay. So I am taking 8255 here. It is 8255. This will be connected to 8086 this side. I am not showing these connections which we have already discussed in the earlier classes. So to one of the ports of this, you have to connect through diodes. This you have to connect to one port. This port has to be programmed as output port. So you can use any port, say port A. Then another port we have to use for inputting this. We have to use 8 pins of this one. So these 4 again we have to take. The status of this one also we are going to take here. As 4 inputs. We have 4 rows and 4 columns. The entire information will be taken into this port. This can be any port. I'll take this as port B. This is PB0, PB1, so on up to PB7. This is PB7. This is PB0, PB1 and so on. This I will take as PA0, PA1, PA2 and PA3. So how to program this port A as output port and port B as input port. Let us take both in mode 0. This also in mode 0. So let us take the address of this one as, which you have derived in the last class, as this is FCH. FCH is the port of address of this one. FDH is port B address. FF is the control word register. Port C is FEH, which we are not using here. Okay. So this also has to be connected to this common. Then what will be this control word to program this port A as output port in mode 0 and port B as input port in mode 0. What will be the control word? So we have 8-bit status of the control word. For IO or mode selection, the first bit is 1. Then this last one is port C lower, so which we are not using. I am just taking as output port. This is port B. Port B how to use as input port, so this should be 1. And this is mode selection for port B. I want to operate in mode 0. This is port C upper, so I am not using, I am taking as output port. This is port A, you have to program as output port, so 0. These 2 bits are mode selection of port A, so I am operating in mode 0, so both are zeros. So what is the hexadecimal equivalent of this one? 8, 2, 82H. So you have to take first 82H into control word register. Okay. Now here the basic process to interface a hexadecimal keyboard to the microprocessor, and then we have to read the corresponding hexadecimal value into say some AL register. If I want to press 0, I am taking this such that AL will be having key value. Okay. So if I press 0, 0 0 has to be taken here. If I press 1, 0 1. If I press A, 0 A. If I press B, 0 B and so on. So whatever the key that we are going to press, that hexadecimal value, so I want to take into accumulator AL. So here we have some hardware as well as I have to write the program also. Okay. So before going for this program, the basic steps in interfacing a keyboard to the 8086 is, we have 3 steps. One is called, first we have to detect the key. Then second one is debounce the key. Third one is decode the key. So, I will explain these operations with the help of flow chart, then I will convert the flow chart into assembly language program. Okay. So, the basic process for detecting the key will be, you output a 0 on any of these ports. Okay. If I output a 0 here, let us first assume that if all the keys are open, no key is pressed. Okay. So, what will be the value here? Because this 5 volts is there, so this 5 volts through this resistor will be normally 10 kilo ohms. Through this resistor 10 kilo ohm, this will be connected here. So, here you will get 1 1 1 1. Whenever you have 1 1 1 1 here, means 1 1 1 1 here, whenever you have 1 1 1 1 here, means no key is pressed. Because these are directly connected. Okay. Here there is no connection here at the interstate. Let us assume that here there are no connections. Connections will be represented by a thick dot. Here there is no thick dot, so there is no connection at these junctions. Okay. So, if no key is pressed, these 4 bits will be 1 1 1 1, because these 5 volts through after some drop across this resistor, that same 5 volts a value will come set this columns, thereby you will get 1 1 1 1 here. Okay. If any key is pressed, what happens? If any key is pressed, suppose let us assume that key C is pressed. So, what happens? This PA0 value will be connected here. If PA0 is 0, so this is 0 volts, this is 5 volts, so this is 0 volts, this is 5 volts. So, because of this short circuit, this becomes 0 volts and a 0 will be appeared here. Okay. If all are ones, means no key is pressed. If any one column is having 0, means there is a one key pressed in that particular column. So, suppose if I get 0 here, the key pressed can be either 0 or 4 or 8 or C. The key pressed will be either of these 4. If I get 0 here, the key pressed can be either 1, 5, 9 or D. So, like that. So, a 0 on any column represent there is a key pressed in the along that particular column. Okay. So, with this basics, I will go to the flow chart and then program. So, the flow chart will be for this. As I have told, there are 3 steps. First one is detect, flow chart. First step is detect, then debounce, then decode. Okay. So, in order to detect, the first thing is we will start, this is start of the flow chart. Normally we will start with this start. Okay. Output 0 on all the rows. So, in the previous slide, so first I am going to send 0 on all the rows. So, these diodes will be short circuited because of this 0, this cathode is connected to 0, anode is connected to some positive voltage. Okay. So, these resistors are so selected that if I send 0 here, so this voltage is greater than cut-in voltage of this diode, thereby this diodes will be short circuited. So, before going to press any of this key, so what you have to do is, first you have to check that all the keys has been released. Okay. So, after all the keys has been released, then only you have to press the key, otherwise you will get a problem of 2 key lockout. There is one problem with switches is called 2 key lockout. is whenever a particular key is struck already. If I press the second key, then two keys will be pressed simultaneously. That particular problem is called two key lockout. To avoid this, first I will ensure that no key is pressed, all the keys are in released position. If I ensure that, then we are going to press the key. Okay. So to check that, so what we are going to do is, we are sending first zeros on this and we will check this status at the columns. Okay. So if no key is pressed, what will be the column status? If I send 0, if no key is pressed, here you should get all ones, means no key is pressed. Okay. So that is the first step. Output 0 on all rows. You have to check whether all the keys has been released or not. All the keys released or not. If no, until the key is released, we cannot press the another key. So it will go here. If it is yes, then I will check for a key that is to be pressed. Okay. Then I will read columns. And read columns also you can write here. Read columns. Key is pressed. Is key is pressed. If yes, we have to go for debouncing. This is for, this entire thing is for the first operation, which is detect. If yes, it will go for debounce, the second operation. Okay. If no, it will wait until the key is pressed. Fine. Then debounce. What is meant by debouncing? So this is one of the important phenomena in keyboards. Keyboards normally will be having nature of bouncing. Okay. So normally, because what happens is, if I have this push button type of the switch, we have two positions, and if I press here, so before making the final connection, it will vibrate because of this mechanical movements of these switches, inertia and all. Due to inertia, the key vibrates before reaching the steady state. This phenomena is called debouncing of the key. That is, if I make from low to high, this is low to high transition. So instead of going to high, so what happens is, it will vibrates. After some time it will settle at high. This is logic 0, logic 1. This is due to bouncing. The reason for bouncing is, as I have told, inertia. Because of the inertia in keys, there will be debouncing. So that is why even if a key is pressed, so I have to wait for some time until it settles down. This debouncing time you have to set. So after this also key is pressed means its original key. Otherwise, this may be due to noise also. Okay. So to avoid this noise effect, so I have to wait for some time. That will be normally 10 milliseconds. Okay. So for that, I have to read columns again. you obtain a delay of, set a delay of 10 milliseconds. Still key is pressed. You have to check, still key is pressed. If no, this will be due to noise. If still key is pressed, this is original key. Okay. If no, because of the noise, so you have to go to this. If yes, then you have to go for decoding. I will continue this here. To connect the big flow charts, so we can use some letter. This is ending of this part. So this second operation debounce is over, and the third operation is decode. Okay. So I am starting here again with A. So this is A means this is linking between these two. This is the notation of the flow charts. Okay. So A, then again what I will do is I will read the columns. Before that, to decode the column, output 0 on one row. Okay. What I will do is I will output 0 on one row. Suppose if I output a 0 on this row, and if I check 0 on this row, if I check these columns, 4 columns, if I get 0 here, what does it mean? So in the first row and first column 0, if remaining 3 are ones, so key C is pressed. Okay. So if I get 1 here, these 3 0 0 0, then key D is pressed. Is it clear? So you send a 0 on any particular row. You check all the columns. At any column, if I get 0, means in that column and that row, the intersection is the whatever the key is present in the intersection, that key has been pressed. Okay. This is the logic to decode the keys. Then read the columns. His key is found. If no, we will go for outputting the row on another row. Initially we will keep this 0 on the first row, then second row, third row, fourth row. We will check for all the rows. If yes, then we have to read the key value. Then stop. This is the flow chart to interface a hexadecimal keyboard to the 8086 microprocessor. Now if I know this flow chart, I can map this flow chart onto the assembly language program. Okay. So here I will write main program as well as subroutine. Okay. So for that the program will be initially the setting is, because we are going to use the subroutine, we have to initialize stack segment, data segment is anyhow necessary. So we take some contents into AX, $5,000, move DS comma AX. We are setting data segment register to 5000, means the starting of the data segment will be 50,000 H. and move AX comma some 6000, move AX contents onto stack segment, means the starting address of the stack segment is 60,000 H, and whenever stack segment is used, stack pointer has to be initiated. The stack pointer I am initiating with say some FFFFH, so that the stack top will be 6FFFFH, 60,000 plus FFFH. Okay. Then the first step is, so these are this in the main program, that I will just call the subroutine, call key. So at key subroutine I will write a part of this program here because I have to explain this flow chart. So the key subroutine. So in this, the first instructions will be you have to push flag register. Whenever you want to use the subroutine, it is always good practice to push all the registers and pop all the registers at the end. Push AX. These are 4 instructions I am writing in a single instruction. BX, CX, DX. Okay. This is the order. While popping, you have taken the reverse order. Okay. Now what is the first step? You have to output 0 on all the rows, and you have to check whether all the keys has been released or not. This is to avoid 2 key lockout problem. Okay. So initially, before going to press any key, you have to make sure that all the keys has been released previously, so that no 2 key lockout problem will occur. Okay. So how to output 0 on rows? Rows are connected to, these rows are connected to port A, whose address is FCH. Okay. I have to send 0 0 0 0. So I will take move L comma 0 0 H, out, rows are connected to port A, so port A address is FCH comma AL. So with this instruction what happens? All the port A pins will be having 0 output. Okay. So in that 4 pins we have connected to the rows, 4 rows. So 0 will be outputted on 4 rows. Then what is the next step? You have to check any keys released or not. So if all the keys are released, what does it mean? As I have told, so all the 4 bits should be 1 1 1 1. So where we have connected these 4 bits, these 4 columns you have connected to PB4, PB5, PB6 and PB7. Okay. So you have to check this PB4, PB5, PB6, PB7. If all the 4 these bits are ones, means no key is pressed, all the keys are released. Okay. So how to check this last 4 bits of port B? How to check the 4 bits of port B? For that you have to write in. I have to take the data into AL. In AL comma the port B data whose address is FDH. So the very first instruction in this program is, I have forgotten. So you have to initialize the ports. As I have computed this, this control load register I have obtained as 82H. This you have to take into control load register. So we can take here anywhere, you can write here also. So the first 2 instructions are move AL comma 82H out FF comma AL. So this will program port A as output port and port B as input port in mode 0. Okay. Because this is just only initialization only. Now in AL comma FDH, okay, in AL FD comma H, AL will comes the data of all the columns, 4 columns. Okay. What I am doing now is I am ending that AL with FFH, ending AL with FFH. Anyhow, the first 4 rows will be 0 0 0 because you have inputted 0 0, this will be 0. If any one of this particular 4 column status is 1, ending operation will result non-zero value. Okay. So that is why I am comparing with compare AL comma 0 FH. This can be either FF or 0F, up to you, because remaining 4 bits we are not using. Okay. Compare AL with 0 FH. So after this, what happens in AL? The 4 bits, remaining 4 bits I am not caring. If the last 4 bits of these 4 columns, if any one of this column is 0, so for example 1 1 1 0. Okay. So this is E 0 E, first will be 8 bits will be 0 E, so it is not 0. Jump on not equal. So when this jump on not equal is true, what does it mean? Jump on not equal. If these two are not equal, what does it mean? So in the 4 columns we do not have all the ones. Okay. One of this column is 0. If all the 4 columns are 1, so the last 4 bits will be 1 1 1 1. So 0F, AL also will be having 0F, and we are comparing with 0F itself. So result should be equal. Jump not equal has to be true. So because if it is not true, go to up 1. So you have to again input this data and you have to check. So whenever this is in loop means all the keys has not been released. So you have to wait until all the keys has been released. So whenever this program come out of this loop means all the keys has been released. If all the keys has released, 4 column bits will be 1 1 1 1. We are comparing with 1 1 1 1 only. So if they are equal, this jump not equal will be true. So it will come out of the loop. Then after that, so this first part is over. These 2 parts are over. Now again you have to read the columns. So for that again in AL comma, where you have to read the columns are connected to port B. Okay. In that port B also the last 4 bits, that is PB4, PB5, PB6, PB7, MSB. So in port B whose address is FDH. So we are reading columns, then you have to check if any key is pressed. If any key is pressed, we have sent the zeros on the rows. If any key is pressed, that particular column should be 0. Okay. If all the column bits are 1 1 1 1, no key is pressed. Okay. Do the same thing MSBF. So I am going to end with this AL contents. In that MSB bits, LSB bits you have sent the 0 0 0 0. MSBs if all are ones means this represent no key pressed. If any one of this bit is 0 means there is one key pressed. Till any one of this bit is 0, we have to wait in a loop. Okay. And AL comma FFH. So if the result is compare AL comma FFH, here this ending this becomes 0, so F0H. So this is anyhow 0. If these 4 bits are 1s, then this will be F0. If these two are same, means no key is pressed. So jump on equal up to. If this is true, if these two are equal, means no key is pressed. So I have to wait until the key is pressed. Okay. For that I have to wait here in the in loop up to. So if it is false, jump equal is false, means in this one of the bit will be 0. Then only this jump equal is false. It will come out of this jump equal, means one key is pressed. So it will come out of this one. So this will be this point. Okay. Then we have to provide a delay. After the delay, we have to again check the read columns. Okay. So for delay, move Cx comma 16EA. In the last class we have discussed about how to compute the delays. So with this count value, if I loop here itself, loop is here itself. Then this program will generate a delay of 10 milliseconds. Okay. This program is basically, these two instructions are basically to provide a delay of 10 milliseconds. Now after this again I will check still the key is pressed. If still key is pressed, means that is the original key, otherwise it is due to noise or debouncing of the key. Okay. Again I have to read the columns. So for that, in AL comma port B address is FDH and FFH, AL comma FFH, compare AL comma F0H, jump on equal. Again the same logic. So equal means if AL is having the upper 4 bits of AL is having 1111, means no key is pressed, means that previous key pressed that we found before the delay was due to noise. So I have to wait until a valid key is pressed. Okay. So I have to jump to again the starting of up 1, this up 1, because we found that the key pressed was due to noise or debouncing effect. Okay. If this is false, means one of this bit is 0, that means a valid key is pressed. So I will come out of the loop, then I have to decode that particular key. The third operation is we have to decode the key. So this is coming out of the loop. So this again to decode the key, these are the steps. These are the steps we have to decode to find the correct key. Okay. So what is that next operation? We have to output 0 on one row, then you read the columns. If key is not found, then you send a 0 on the second row, third row, fourth row, like that. We have to check for all the 4 rows. So you have to output here, now you have to output 0 on one row. Say I am going to output 0 on the first row, which is connected to PA0. The first row we have 4 rows. This is connected to PA0. Of course the diodes are there here. This is connected to port 1. PA0, this is connected to PA0. PA0, PA1, PA2, PA3. First I am sending 0 on the first PA0. So what is the instruction to send the 0 on PA0? What are the instructions required? In AL comma FEH. Okay. So FEH means 1111 1110. So only this least significant bit is 0, remaining all bits are 1s. This I am going to output onto port A. Port A address is FCH AL. So with these two instructions A0 will be sent on PA0. Okay. Then I have to check any column is pressed. Okay. If not, I have to go for the next key to be pressed. Okay. So here this FE, I have to use 0 here now. I have sent 0 here, next I have to send 0 here, next I have to send 0 here, next I have to send 0 here. But this AL I am using for some other purposes. So I am keeping this value of AL in CL also. So that even if I use this AL for some other purpose, the original contents of FE will be present in CL. Okay. So after sending a 0 on one row, what you have to do? You have to read the columns. If key is not found, you have to repeat the same process. Read the columns. What are the instructions to read the columns? Columns are connected to PB4, PB5, PB6, PB7. So in simply basically to read the columns in AL comma port B address is FDH. Okay. Now in AL we will be having port B. In this the last 4 bits will be, this will be 4 columns. This will be 4 columns. This will be of course 4 rows itself. Okay. So in the 4 columns, so I will check if any column is receiving a 0, means in that particular column a key is pressed. Okay. So if any one of these 4 bits is 0, means key is pressed. If all these 4 bits are 1 1 1 1, no key is pressed. Okay. Then and AL comma, this is of course whatever this 0 FH, compare AL comma 0F. Okay. After ending also if I get 0F, what does it mean? These are 4 bits are ones only, so no key is pressed. So jump on equal, if this is true, what does this mean? So this is no key is pressed, so you have to go for the next row. Jump on equal, go to next row. If they are not equal, means key is pressed, you have to decode. Okay. So next row means where should be this next row? Otherwise I will write jump not equal so that this will be easier. Jump on not equal. So if these two are not equal means key is already pressed, we have to go for decode. Otherwise you have to go for next key. So before going for the next key, what I will do is, because I have to send 0 here, this contains FE was there in CL, so I will take again that move CL comma rotate accumulator, PA0 becomes PA1 means to the left, rotate left CL comma 01. So that in CL what will be present? This FE 1111 1110. You are rotating this, this will come here, this will come here, this will come here, okay, like that. So this will goes to here, okay, this becomes F 0010 becomes E F sorry D FDH. I am taking this into AL again, CL, unconditional jump to next row. Here this is equal means already key is found, you have to just decode. If not, you have to go for the next key check. So where should be this next row? Next row will be here. Now we have sent we have to output this value, sorry, here, next row. You have to output and you can save that value FD, because in the next round I have to shift this FD by one more bit. So I am saving into CL again, and then I am going for this inning of this columns. So this process will repeats. So once this come out of this loop, when does this will come out of the loop? If any one of the column is found to be 0. Okay. So then whatever this row that have sent and the column, these two we have to use for encoding or decoding the program. This is I am calling as decode, but the correct word is encode. Okay. So you have to encode that particular key. So for that I can use the lookup table. This is something like, so I have 4 rows and 4 columns. Okay. So along this row we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Okay. Anyhow, this we are reading in port A. In port A we are taking this as, in port A we are taking this PA0, PA1, PA2, PA3, and this you are taking in PB. In addition to this we are taking this also. Okay. We are taking this also in PB also. This we are taking as PB0, PB1, PB2, PB3, this is PB4, PB5, PB6, PB7, PB0, PB1, PB2, PB3, PB4, PB5, PB6, PB7. Now this lookup table will be, suppose if I send on this port B itself, if I send 0, 1, 1, 1, okay, and if I receive same 0, 1, 1 is available here also, 0, 1, 1, 1. If I receive 0, 1, 1, 1 here itself, what does it mean? In 0th row, 0th column key is pressed, which is C. Okay. So like that, if I want to press key 0, so what will be these values of PB0, PB1, PB2, PB3, PB4, PB5, PB6, PB7. Okay. So 0 key pressed means 0 is here, so this row should be 0 and this column should be 0. So what is the corresponding code? This will be 0, 0, 0, 0, because this row is PB3, PA3 as well as PB3, and this row is PB4. If PB4 is also 0, 0, 1, 1, sorry, this 3 should be 1, 1, 1. I have to send 0 in any one of the rows. 1, 1, 1, 0. If I send 1, 1, 1, 0, means PB3 is 0, and PB4 is also 0, the remaining 3 are 1s. So this code is correspond to key that is pressed as 0. Okay. In port B, this we are going to take this 8 bit of the data into this port B. In port B, if I receive this code as E7H, in port B, if I have E7H, means a key 0 is pressed. This is correspond to key press 0. Similarly, what about for key 1? Key 1 means 1 is here. So this should be, these 3 should be 1, 1, 0 only. This will be 1, 0, 1, 1. So what will be this one? This PB 0 to PB3 remains same, because 1 is also in the same row as 0. So 1, 1, 1, 0. Column will be, this 0 will be available here. 1, 0, 1, 1. So now what will be the code? E E B. This is the code corresponding to 1. Okay. Similarly, you can derive for 2, 3, so on up to F. Then that value I want to take into accumulator. Okay. So this only the thing that is remaining is how to encode, how to read the key value into the AL register. That part we will discuss in the next class. Thank you.